So start up by just having the blank fractions, finding the smallest number that goes into two of these. Now, a lot of the time, it is the product of the two numbers. Like here, it's just basically 7 times 4 is the correct number, right? And then figure out what do you need to do to get from 7 to 28. Multiply by 4, top and bottom. And what do you need to do to get from 4 to 28? Multiply by 7. Okay. So we got 21. Then you can add them up. 33 over 28. There we go. And subtraction is very similar, just subtract for that. Not too bad. That cannot be simplified. Yeah, this is 3 times 11, which none of those go into 28. That's next. So let's move over to 3. Let's review the multiplying. So now, rules are different. No common denominator, and we can cross cancel, which is good because this makes things a lot easier. So go ahead and look at the diagonals. Is there anything that goes into 5 and 10? And anything that goes into 9 and 12? Okay, so let's do the 5 and 10. 5 goes into 5 one time. 5 goes into 10 2 times. And then the other diagonal, 9 and 12, 3 goes into 9 3 times. 3 goes into 12 4 times. And from there it's top times top, bottom times bottom. So 2 times 4 is your 8, and 3 times 1 is 3. And we can leave it as an improper fraction. You don't have to change that to a mixed number as long as it's fully reduced. That's what you got to make sure of. So that one's done.
What about the ones that have a whole number with it?
Yeah, the mixed numbers. So let's go down to 6. So we know how it works when it's improper fractions, right? We just cross cancel and multiply across. So if we know how that works, let's convert them to improper fractions, and then we can just do the same steps as number 3. So starting number 6, let's just convert both of those to improper fractions. So it's 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. Keep the same denominator. And then the same thing with the second fraction, right? 1 times 7 is 7, plus 5 is 12. And now same steps as above on number 3. So cross cancel, 7 goes into 7 one time, both there and there. 2 goes into 2 one time, 2 goes into 12 6 times. So on the top we have a 1 times 6, which is 6, and the bottom 1 times 1, which is 1. Anytime it's over 1, that's the same as the whole number itself. So we can write that as just 6. Good. Okay, coming up. So let's look at some division now. Let's go back to number 4. And when we looked at this last week, I remind you that dividing something by 2 is the same as taking half of it, right? If you ever divide something by 2, that's the same as taking half of something. So dividing by 2 and multiplying by a half mean the same thing logically. So it also works with every number. If we want to divide by 8/5, it works that we can multiply by 5/8. Kind of like if we can divide something by 2, divide something by 2, that's the same as taking half of it, right? So it works for every single number. So we can do 2/5 times 5/8. So it's not just some math rule that someone just made up, but that's the way we think, and that's the way it makes sense logically. And then same rules as number 3 and number 6. You can cross cancel if possible. Let's go ahead and do that. So 5 goes into both of them one time. And 2 goes into 2 one time. 2 goes into 8 4 times. So we have 4. And we have, now is this 4 on the top or the bottom? Bottom. So what goes on top? 1. So 1 times 1's on top. So the question might be, well, how come I have to put the 1 here, but then on number 6, the 1 here I didn't. I left it off. Yeah. Well, the short answer is, well, you know, if it's the 1 on top, you got to keep it. If it's on the bottom, you're allowed to drop it. Okay. So long answer is that this means 1 out of 4, 0.25. You put it in the calculator. 1 divided by 4 is 0.25, like 25 cents, 1/4. Okay. 6 over 1, put in the calculator. 6 divided by 1 is 6. That's why we don't need the over 1. All right, so now we know how to divide. It was a keep, flip, flip, keep, change, change, some people like. Let's look at number 10. 10 is very similar to 8 with mixed numbers. So let's combine them all together in number 10. Now also recall that something like this, 1 over 4, 1/4, that actually means 1 divided by 4. Fractions are division problems. Fractions are unsolved division problems. It's just a little bit easier to work with it that way than to make everything a decimal. So we can rewrite this division right here with this division sign. Instead of using division bar or a fraction, we can rewrite it using this symbol because that's what we're kind of used to. Like on number 4, we're used to having a division symbol, not having a fraction bar. So let's rewrite this as 5 1/4 divided by 3 1/2. You'd say these two out loud identically. This means 5 1/4 divided by 3 1/2. It's just how you write it is different. Okay. So now we can convert them just like we did earlier on number 6. Convert them first to improper. So we got 5 times 4 plus 1. All over the same denominator, 4, divided by 2 times 3 plus 1, 7. Same denominator as 2. And now we got to do the same thing we did in number 4, right? We got to keep, change, change. So we got 21 over 4. The front one always stays the same. Nothing changes there. That's the key. Keep it the same. And then we can change division to multiplication and change 7 over 2. 2 over 7. And from here, same steps, cross cancel if possible, multiply across. So let's see here. 2 goes into 2 one time. 2 goes into 4 2 times. 7 goes into 7 one time. 7 goes into 21 3 times. And then multiply across. 3 times 1. 2 times 1. So you get 3 over 2, which is the same as 1 1/2. So we can leave it just like this. Okay. So that will get you through the front and the beginning of the back. But let's look at those word problems on the back really fast to get you started on 16 through 18. So these we just have to figure out, well, what should we add, subtract, multiply, divide? So if we read this, Jasmine wants to make some cookies. She wants to make 2 batches, but she knows the recipe for 1 batch calls for 1 1/4 cup of flour. So she knows 1 batch is 1 1/4 cup. How much for 2 batches? So a couple ways of doing this. You can take 1 1/4 and say, what's 1 1/4 times 2? Right, that's twice as much. Or you can just say, well, 1 batch is 1 1/4, and the other batch is 1 1/4. So you can just add, because it's only times 2, it's not that hard just to add the fractions together too. If this was times 7, we wouldn't be adding 7 of these together. But there are 2 ways that are perfectly fine for doing that. So you pick the way you like and go ahead and solve it. What about number 17? It's snowing on Mount Baldy. Monday it snows 3 2/5. Tuesday it snows 2 3/4. How much altogether? Should we add, subtract, multiply, divide? What do you think? We're trying to find out the total, right? What do you think? Yeah, add them up, right? So you can just take those 2, add them together, find out what the total is. Lastly, on number 18, we have a string that's 20 inches long. It's really long. And we want to cut these small pieces that are a little over an inch. How many can I get without actually cutting it? How can I figure out how many I'll get without actually cutting it up? And divide it up, yeah. So you're dividing it into sections that are 1 1/4. So you can do 20 divided by 1 1/4. And we solved that on the front, something similar to it. Okay, so you can finish that up. You'll have a little bit of time tomorrow, beginning of class, and then we can take the quiz. Good luck.